Okay, students, so next is question number 13. After that, we will do question number 7. Okay, triple definition. So this is double definition again. So in this question they have asked you, is the function defined here is continuous or not? So you have to find out the function is continuous. This time you don't have to find out the discontinuity. Okay, what you have to find out, whether this function is continuous or not. So same concept of discontinuity we will apply here also. So how we will apply that concept? So see here, what the function is defined is fx is equal to x plus 5 when your x is less than equal to 1. Means if you take it in the graph, whenever x you take less than or equal to 1, your graph will be x plus 5. Means if you take 0 x 0, then your y will be 0 plus 5. That is 0 plus 5 will be how much? 5 only. So 1 2 3 4 5. So it will be somewhere here. Okay, 1 2 3 4 5, somewhere here. Okay, next if you take 1, your y will be 6. Why? Because we have taken this function. Whenever x is less than equal to 1, we have to take y as this one. Okay, and when you take greater than 1, means just after 1 whatever is there, those if you take it as x, then your y will be x minus 5. X minus 5 means somewhere here. Okay, so we have to find out whether this function is continuous or not. Continuous means whether the graph will break or not. So easily we can find out this also. Okay, so see here, so what we will check, less than 1 we will not check, because less than 1 x plus y will be the function, so obviously it will not break. This is a straight line, right? So right after 1 there will be a straight line. If you take x equal to, suppose 1 equal to 1, if you take, then your y will be 6. So somewhere here 6, right? Just next to this, okay, in your left next to this, whatever x you will take, say 0.9999, like that you will take. If you take like that, what will be your y? 5.9999, like that. So it will be just here. Okay, so this will form one line. Next point will be here, like this. It will keep on moving. Okay, this points, and it will form a straight line. We know that this will represent a straight line. So from here we will get a straight line, and it will never break. That's confirmed. Okay, because this is defined for all value of x less than equal to 1. Whatever x less than equal to 1 you will take, y will be there. Okay, so it will be a continuous line here. So here we are not going to check whether the graph will break or not, because it's confirmed that it will not break here. The chances is here at 1, because after this greater than 1 there is another definition, right? Function is this one. So this graph may come from here like this, or like this, or it may come from here only. If it comes from here only, then we will say that the graph is continuous. It's all real number. So greater than 1, it's confirmed. If you take greater than 1, this graph will not break. That's confirmed. But where it will take a start, from here or here or here or here, or exactly from here it will take start, we don't know that. Okay, so when you take greater than 1, we don't know whether it will start from here or not. If it starts from here only, then we will understand that it will be a continuous function at all point. Why all point? Because I'm not going to check for rest of the point. Greater than 1 if you take, obviously this graph will not break. Again, continuous graph you will get, right? So the chances is on 1. The graph might break at 1. That is the only chances. Rest of the point it will not break. That's confirmed, because these are straight line. Okay, less than 1 if you take, it will represent a straight line. Greater than 1 also it will represent a straight line. But this graph will join or not, both, that we have to check. Okay, if it joins, it will be continuous at all point. If it does not join, then it will be discontinuous at 1 only, because rest of the point it's confirmed that they are not going to break. I hope you can understand this one. So let's start. So what we will do, at x equal to 1 we will check whether the graph will break or not. So, okay, so left hand limit find out, right hand limit find out, and f of 1 find out, and check whether these are same or not. This was your definition, right? So left hand limit, how you will write down, limit x tends to 1 minus fx. So 1 minus means less than 1, right? Just less than 1, that is x plus 1 will be, x plus 5 will be a function. Limit x tends to 1 minus x plus 5 is equal to, what you will do, 1 you'll put here, 6. Limit x tends to 1 plus fx, limit x tends to 1 plus, now 1 plus means greater than 1, right? On your right, one closer value on your right, that is x minus 5 will be your function. So x minus 5, if your function, if you put 1 here, what will happen? 1 minus 5, it will be minus 4. So you can see they are not same, so obviously the graph will break. So for the formality, we will find out f1 also, okay? So f1 will be how much? Now when your x is equal to 1, which function you will take? This one, x plus 5, that is it will be how much? 1 plus 5, it will be 6. So okay, fine, no problem, that left hand side and this one, left hand limit and this one is equal, but right hand limit it's not same. And for continuous function, you know all values must be same here, right? So what we will write? So at x equal to, you can say, since left hand limit, right hand limit is not equal to, you can write in this way, or you can write simply like this, limit x tends to 1 fx, this is much better to write down, f1 is not equal to 1. Therefore at x equal to 1, the function is discontinuous, the function f is discontinuous, okay? And you have to discuss for all the points here, right? So you have to mention here. In previous question, what we have done, we have just mentioned at what point the discontinuity was there, right? In this question, we have to mention that it will be continuous on the rest of the value of x, okay? So why? Because in this question they have asked you, is the function continuous or not? You have to check that. So you have to mention everything about all the points. So what we will write? At x equal to 1, the function is discontinuous, right? So how I will write down? Therefore f is continuous for all real number. Real number, how we can write? X belongs to, for all x belongs to R, real number. But at 1 it is breaking, right? So how you will write down? Except 1. So this can we write down like this? F is continuous for all x. X belongs to R. For all x, you can see it will be continuous except at 1. At 1 it will break. So how I have written that one? Except 1. So I have excluded 1 from the real number, set of real number, okay? If you want to check graph of this one, you can check. You can plot this one and can check. You will see at 1 it will break. At x equal to 1, the graph will break, okay? You can check that one. So let's move to next question, that is triple definition. Very important question, question number 7. So if you have understood all this double definition, then triple definition, it's not tough. You just need to be very careful with the values, okay? So question number 7. You have to find in this question the point of discontinuity. Discontinuity means in the graph where the graph will break, okay? Now see, for all point it's impossible to find out, right? So you have to make idea from the function only, from in which point you will check whether the graph will break or not, and rest of the point you must be confirmed that it won't break, the graph won't break. So see how we will check that one. Like in double definition, same here, the only thing is here triple definition. Now see carefully, they have said that if x less than equal to minus 3, then the function will be this one. Less than equal to minus 3 means minus 3 will be somewhere here. So less than equal to minus 3, if you take x, your function will be this one, okay? Y will be this one. So I have to check for all this left side value. I have to check whether the graph will break or not, this graph will break or not, okay? Next, till minus 3 to your left values, we have already got the function, right? Now minus 3 to 3, this is not equal. Between this, whatever numbers are there, okay, x, whatever values are there, the graph will be this one, minus 2x, okay? Between minus 3 to 3, this is what the meaning of this function is. X greater than minus 3, when you will take x greater than minus 3 and less than 3 means this value is, right? Okay, open interval. I hope you remember all this. So when you will take x this values, then your function will be this one. So here I will check whether the graph will, obviously 2x will not break. Between this one, the graph will not break. the chances is at -3 this might break. See, from -3 you will get this graph, right? So obviously this will not break. This is a straight line again. We will redefine this one, since modulus is there, we will redefine this one, but still you can understand this is a straight line. So obviously on your left the graph will not break. Like this it might go. So at when you draw for greater than -3, so there is a chances that this graph might come from here till 3. They have said it is 2x, right? So 2x function will not break, but the problem is it might break here only at this point -3, because this graph we don't know from which point it will start, from this point or from this point or this point. We don't know from where it will start. So if it starts from here only, then it will be continuous at this point. If it does not start from here, suppose it start from here, then we will say that it is discontinuous at x equal to -3. Now between -3 and 3 there is no chances of breakage here. Okay, there will be no break here in this graph. Why? Because the function we know it's a linear polynomial, again same straight line it will represent, right? So till 3 I am confirmed that this will not break. So first step what I am doing is at what point the graph might break, I am trying to find out that only. Okay, so at -3 the graph might break. Now between -3 and 3 obviously the graph will not break, because the function is what? 2x. Whatever value you take, y you will get it. So this kind of graph you might get. So at 3 it will stop, right? Not 3, just less than 3 it will stop. Now next graph will start from x greater than as well as equal to 3. So from here as well as greater than 3. This will be the function. Now when you will draw graph for this one, x you will take equal to 3 and then we'll plot y. So that y might be here or here or here, or it might be here only. Okay, if it is here, then rest of the points obviously it will represent a straight line. It will go like this. If it starts from here, it will go like this or like this or like this, then it will be continuous here. But if it takes start from here, then the graph might go like this. After that it will represent a straight line, that we know, 6x plus 2. It will go here or here or here, but it will break at this point. I hope you can understand. So the chances of breaking is at 3 and at -3. So at this 2 point we will check whether the graph will break or not. Rest of the point you can understand that it will never break. Okay, so where we will check at -3 we will check the function will break or not, and at 3. Okay, I hope this is clear. So this you can understand from your previous knowledge only. You need to understand what kind of graph it will represent. A straight line, straight line, straight line. So when you will take x less than -3, then your graph will be this one. So when you will plot this graph, it will be like this. From your x equal to -3, from here it will start the graph. Now just next to this you are taking the point, right? So for that also y you will have. Now if that y is here only within this alignment, if it is here, then we know that the graph will start like this or like this or like, because this also will represent a straight line. So if it is here, that point at this function, if it starts from here only, then we will say it is continuous. If it does not start from here, we will say it is discontinuous. Obviously we are not going to check with graph, we will check with the help of limit. That is much more simple actually. Okay, now those who are finding it tough, means you have not seen limit video. Okay, limit definition which I have explained there in the video, you have not seen that one, that's why you will not understand limit concept. So you have to watch that video and then only you will understand all these things whatever I'm saying here. Okay, so it will not break here in between, again I know. Now at this point it will stop, just before 3 it will stop this graph, right? So this is the graph of this function, suppose. Now next graph when you will draw, you will start from x equal to, just next to this point we will take x equal to 3, right? Because less than 3 we have already drawn graph, so it will stop here. Next point when you will draw graph, if it starts from next to this point here only, then we will say the graph is continuous, means it will not break. But if it starts from here, then the graph will break here only, right? Rest of the point obviously after this will not break, because 6 plus x plus 2, it's a straight line, so it will represent a straight line like that. Okay, so it will not break after that. So the chances of breaking is at 3 and at -3 only. So this is the very important step in continuity which you need to understand. So most of the student, what they used to do is, they don't try to understand this graph, and what they used to do is they just simply memorize the step of limit. Now when you will memorize the step, I told you, tricky problem like this one, you will face problem in this kind of question. You will be in trouble, okay? So if you want to understand these things properly, always try to follow this graph. First try to understand these things, then easily without drawing graph also you can easily solve this problem. Okay, so let's solve this. Now the chances of breaking is at -3 and 3. Rest of the point it will be continuous, I know. So at -3 first, x equal to -3. Find out left hand limit, right hand limit, and f of -3. Then at x equal to 3 we will find out whether these values are same or not. Left hand limit, right hand limit, and f of 3. Why we used to check all this also I have explained in the previous video, okay? So left hand limit, when you will find out limit x tends to 3 minus limit x tends to right hand limit 3 plus, and this will be f minus 3 means directly f minus 3. When your x equal to -3, which one will be the function? This one. Okay, first we have to redefine this one. So here only I will redefine, okay? So see what you are taking, x less than equal to -3. So x you are taking which values? Negative values only, right? So if your x itself is negative, okay, if it is suppose -3, what will be the output of this one? +3. Means whatever x you are taking, same value does not come out, opposite sign used to come out, right? So what we will write, instead of writing mod of x, I will write minus x. Output will be minus x, right? Because if it is -3, the output will be what? 3. So see, if it is -3, it will be minus minus plus 3. So instead of modulus this one, if I can write this also, same value it will give. So that's why modulus I have redefined like this. And in this case plus x, why I am not taking? Because x is only negative value, positive value is not there. Okay, that's why I am not taking x plus 3 only. This time only minus x plus 3. This is redefined, okay? So left hand limit 3 minus less than 3. So this will be the function. So minus x plus 3. fx plus, let me write down. Limit x tends to 3 minus, function will be minus x plus 3. So put the value 3 directly here because determinant value, right? So if I put, this is -3, sorry, -3. So -3 if I put directly here, what you will get? +3 plus 3, that is 6, right? So right hand limit you find out now. fx directly I will write 3 plus means greater than 3. Greater than 3 which value? Which function? This function 6x plus 2. 6x plus 2. X if you put here, 3 if you put directly here, what you will get? -3, sorry, again. This also -3, yeah, okay. -3 if I put here, what you will get? 18 minus 18 plus 2, obviously you are not getting same, that is -18 plus 2, that is -16. So this and this not same means the graph will break here, confirm, okay? But still for formality we will find out f minus 3 also. F minus 3 means equal to 3 minus 3. X when you take equal to -3, this will be the function. So -3 if I put here, you will get 6. So limit x tends to -3, fx is not equal to f of -3. So the graph will break here, okay? Next at x equal to 3 we will find out limit x tends to 3 minus fx. So this will be less than 3. Less than 3 will be this function, right? This is +3. So less than 3 will be this function. So -2x. So if I take function to be -2x, what will be the limit value? So 3 if I put here, 6. -6 you will get. Next find out right hand limit. Limit x tends to 3 plus this one. fx is equal to limit x tends to 3 plus fx is how much now? 3 plus means greater than 3. Greater than 3, this is the function 6x plus 2. So if I put 3 here, 18 plus 2, this is also not equal. So we can easily say that here also the graph will break. So for formality again we will find out f3. f3 is how much? when you take x equal to 3, x equal to 3, which one, this function, so 6x plus 2, so if I put 3 here, you will get 18 plus 2 20. So they are not equal, since limit x tends to 3, fx is not equal to f of 3, therefore f is discontinuous at x equal to minus 3 and x equal to 3, and rest of the point it will be continuous. But I don't have to mention here. Why? Because the question is all about finding discontinuity, right? Point of discontinuity. So these are the points of discontinuity. Rest of the point we know it will be continuous, so no need to check rest of the point. So if you want, you can mention, and rest of the point it will be continuous one, okay? But in this case no need to mention, because they have just asked you where the graph will break. Here and here we have already mentioned.